The second half of 7.2 problems have to deal with interest problems. And these interest problems, there's two formulas that we're going to be using. So for an initial investment of P dollars, that's called your principal, compounded n times per year at an annual rate of R, this has a value after t years of A equals P times 1 plus R over N to the NT. Now, this compounding, what that means, and I've written that here in orange, how often they give you your earned interest. So you're constantly, technically, making interest on your account, right? Now, if they wait, so say you put $500 in, if they wait until the end of the year to give you your, let's say you make 2%, if they wait until the end of the year to give you your $10, then the whole year you've only made $10. But what if they actually give you small amounts of your gained interest every month? So, you know, over 12 months you made $10, so that means in 1 month you'd make, you know, 83 cents or whatever. All right, so at the end of every month they decide, oh, we're going to go ahead and give her the 83 cents. So now instead of having $500 that they're giving you interest on, you actually have $500.83 that they give you interest on. So that's what this R over N does. So it takes the yearly rate and it divides it by how many times they're going to give you interest. It's kind of like instead of just one time per year, they're going to divide 1 year up into, you know, say 12 mini years. So instead of a rate of 2%, you have a rate of 2 over 12% because every month they're going to, you know, start over. What this does is it marginally increases the amount of money that you gain. So we could do it, you know, quarterly, which would be 4 times a year, monthly, weekly, biannually, daily, etc. Right? Now, in a bank statement, or if you have some kind of like interest gaining item, they actually will tell you in the fine print how they do it, like how often it's compounded. So like I have one account that I think is compounded biannually, so twice a year they give me interest and then restart. And then I've got other ones that are compounded, you know, quarterly. Okay, so we can imagine, so you get your 83 cents at the end of the first month, and then the next month, instead of having just the $500, you have $500.83, and you get another 2%. So really, in a year, you'd make $10.02. Now, they're only going to give you for 1 month, so you get another 83 cents. Now, because it's cents, it rounds just to 0.83 like before, but the previous one was 0.83 repeating. This one's 0.8347, so it actually is slightly larger. So now that goes into your account, and by the end of February, you actually have $501.66. You have more money that they're going to be calculating your interest on already just by the second month, if they're doing this monthly. All right, so we can imagine if we compounded, if we gave interest, we're given our interest every, not just month, not just day, not just week, but every hour, every minute, every fraction of a minute, as often as possible, then we get what is called continuous compounding. So you can imagine if you could do it infinitely many times at all times, that would be what we call continuous compounding. And note, this looks a little bit like our E. Remember, E was 1 plus 1 over N to the N, as N goes to infinity. So as I compound more and more and more and more and more and more, this thing is actually going to the number e. So compounded continuously is going to be what I call PERT. P-E to the R-T. When you do these problems, you either are going to use compounded n times or compounded continuously. If they say compounded continuously, then you're using this one. Otherwise, it has to be this one, and you have to figure out how many times it's being compounded. So as a first really basic example, I just want to do one where we have some amount of interest, some amount to invest, a yearly rate, and a fixed time, and I just want to do it at a couple different compoundings just to see how it changes over different intervals. So Casey has $1,200 to invest. She invests it in an account that makes 2.1% yearly interest. How much is the account worth after 3 years? So the only thing I'm going to be changing in each one of these is just how often it's compounded. So for compounded quarterly, well, there's 4 quarters in a dollar, right? And 1/4 of something is a fourth. So this is going to be n equals 4. For monthly, we're going to be doing n equals 12. And for continuously, that's going to be our PERT. So let's go ahead and do these. Now my suggestion is when you figure out which equation you're going to be using, then write down each of the letters that are in that equation. So A, P, R, N, and T. So the solution for part A, we're going to look for all of these letters. So the principal is how much you start with, the P. So it starts with $1,200. The rate is 2.1%, which is 0.021, right? How about T? T was 3 years, and then N is the number of times compounding per year. So this one is compounding quarterly, so it's 4. So they want to know how much is it worth after this time. So A is the thing that I didn't have, and it's the thing that I'm looking for. So everything kind of lines up. All right, so my equation is this. And as much as possible for typing this into a calculator, I really don't want to simplify too much. All right, so P, 1 plus R over N to the N times T. So depending on the calculator you have, it may be better to simplify this, or it may be better to just type it in as you have it. So for this type, and really you guys can access the internet on, right? You could type something into Google. You could type this exact expression into like Google and it would calculate it for you. So I want to type in my calculator exactly what I see here. So I'm going to move this over. 1,200 times 1 plus R over N. So I put my division in parentheses here. On my calculator, I actually do have a fraction button, which I can use. So if you have that, that's okay. If you don't, you'd have to type it like this. Okay, and then that thing raised to the, I'm going to use parentheses again, 4 times 3. If you have this power like I do, you don't have to put in parentheses. If you have the caret, like this one, you do need to use parentheses. Okay, so I hit enter. I have 1277.82. So that means after 3 years, this is worth $1,286. $77.81. So a question I could ask is how much did she make in interest? And your answer would be $77.82. Right? You just subtract the starting amount from the ending amount, and that's going to tell you how much interest she made. Now that's different from making 2.1% interest for 3 years, right? So 2.1% of 1,200 is 2520, which if you multiply by 3 is only 7560. But she made $77.82, so she made $3 more than she would have if you calculated just through this basic multiplication, and that's because of the compounding. Okay, so B said it's compounded monthly. So I'm told something other than continuous, so that means I have to use this equation. The principal is 1,200. The rate is 2.1%, which is 0.021. The number of years is 3. And the times per year is 12. So it's compounded monthly, which means 12 times per year. And it wants to know the amount at the end, which means A is the thing I don't have. So A is P times 1 plus R over N to the NT. And I just substitute in all my values. So 1 plus R over N to the NT. So see what's happening here. I'm almost changing, instead of having 3 years, I'm having 36 years. Years in mega quotes here. So 12 times 3, because each year is going to be worth 12 total units, and that means I have to divide my rate, because it's per year. I'm going to divide the year into 12 subunits. So not only do I have to change my rate, but I have to change how long this account is gaining interest for. All right, so again, calculator. I'm going to show you guys how you can type it on one that looks like this, that has the caret key. So 1,200 times, I think you have to write the times, 1 plus parenthesis 0.021 divided by 12. So I close my parenthesis and then I have to close it again. Raised to the 12 times 3 power. Now 12 times 3 is 36, so you could just as easily type in, raised to the 36th power. All right, so we get 1277.96. So she's made an extra, 14 cents or whatever. So $1277.96. All right. Now the last one, C, says compounded continuously. Now because it says continuously, that means I'm using PERT. All right, now with the PERT, remember E is a number, so it doesn't go in my list. The principal is still that 1,200. The rate is still 0.021. The time is still T. The amount is still the thing that we're looking for. So I want A equals P E to the RT. So 1,200 times E to the 0.021 times 3. All right, and at this point, you would use a calculator. So back to my pink one. So 1,200 times E. So my E button here is attached to the LN. So shift or second key LN and I want 0.021 times 3. Now, because I have like the power going as a superscript, I know I don't need the parentheses. It's never wrong to include them though. All right, so 1278. .03. So of course the compounded continuously is going to make you the most money. Although when you're only doing like $1,200 at 2%, the differences are fairly small. All right, if you're told continuous compounding, you use PERT. Otherwise, you are using this formula, and you have to determine how many times it's compounded per year based on the words that they use: quarterly, monthly, weekly, semi-annually, etc.